Hello. It's a difficult task for me to talk to you after lunch and also almost at the end of the school, so I believe everyone is tired. So I'll try to make this lecture more like entertaining than difficult. I'm kind of both from industry and from academia. Because originally and actually I work as an associate professor. I teach courses related to artificial intelligence, and I work as a consultant at Yandex. So today I will be talking about Yandex technology for building agents. So basically how to use models in the cloud. And to make it a little bit more entertaining, what we'll be doing will be creating a coding agent of our own, so our own coding agent, during the next 90 minutes. So hopefully that would be fun. I would be showing you how to do that. You will relax and enjoy and see how it works. So just to wake you up a little bit, who is actively using coding agents for your work, for coding? Everyone, not everyone, but like half of you. And there would be some Cyrillic, don't worry about that. So I will start with giving some overview of what is AI Studio. Then I will show how to use programmatically large language models in the cloud, what's the latest APIs to do that, show one interesting example, visually interesting example of an agentic loop, how agentic loop can improve things. And then we'll actually start and look into OpenAI agents and how to make our own agent for data analysis. Not so much coding agent, but data analysis. That's what we'll be focusing on today. So interestingly enough, just to tell you a little bit more about myself, I started doing things in AI back in 1995. So I believe that's really a long time ago. AI was very different then. At that time, AI was mostly about extracting knowledge from human beings. So I came to one doctor. We worked with one doctor from a hospital in Moscow, and I extracted knowledge from him by talking to him. And once I come to him and I saw a portrait, like an art portrait, which one of his patients presented to him, like full scale, large oil portrait. And I thought that it's really pretty cool to have such a portrait. I mean, I also wanted to have one. I thought, how can I get a portrait? I sent my daughter to art school. So my daughter, who is here somewhere, she went for 10 years to art school, but she refused to draw the art portrait for me because she said that's old technology, we don't use oil anymore. So luckily, artificial intelligence a few years ago, you know, when Stable Diffusion appeared, could do that for me. And the reason I'm talking about that is that well, we are living in a very strange world where creative things, like the things that we thought are creative, can be done by a machine without any soul, without anything to feel. But it can be perfectly done. So, and at that time, also the reason I'm talking about that is to tell you that I was doing things with agents back in 1995. But agents were very different at that time. But the main idea of agents was the same. The idea was to make a computer program work for a long time to perform a complex task without human intervention, or with minimal human intervention. That's the idea of agents. We want a computer to work on its own on a difficult task. Back in 1995, of course, people were talking about multi-agent systems, and multi-agent systems is about like many agents talking to each other. But to make multi-agent systems, to make intelligent agents talk to each other, is a difficult task because you need them to talk in the same language. And by saying the same language, I don't mean English or Russian or Chinese. I mean, they need to have like the same terminology. They need to understand concepts in the same way. So back in 1995, people had to build special knowledge representation languages. They had to talk about ontologies, how to build hierarchies of concepts so that agents understand the world in the same way. But nowadays, you don't have to do all of that because large language models take care about the world model. They take care about agents having the same ontology, and they take care about agents talking the same language. They can talk basically in a natural language, right? So if we consider like evolution of large language models, initial large language models are about just taking text and continuing the text, like text completion. After text completion, like we can make LLMs solve more complex problems by adding reasoning. Reasoning is a kind of multi-step process which helps LLM to solve more complex problem, but it's still one kind of problem limited to one text completion. Then we can, of course, do like things like multi-turn conversation when we talk to chatbot for, like we talk to him in a longer dialogue, and we can together solve complex problems, but it requires human being to talk with the agent, with this LLM. In order to turn LLM into an agent, what we need two things. We need tools for LLM to interact with the environment, and we need agentic loop so that agent like goes on and on and on and on until it solves the problem, right? So those two things are essential in order to build like agentic systems. So that was an introduction. Now I'm switching to Yandex AI Studio. So Yandex AI Studio, first of all, like whenever we talk about large language models, most of the time we want to run them in the cloud, especially if we are using agents, because for agentic capabilities, for tool calling, for all the things that we'll be talking about today, we need rather powerful models. And powerful models, they normally live in the cloud. In Russia, there are a couple of providers who provide large language models in the cloud. Yandex was one of them. And in Yandex Cloud, for a long time, like for a few years, there have been available large language models, both Yandex own models and open weight models like Qwen and DeepSeek. At some point, like about a year ago, maybe a little bit less than a year ago, Yandex decided to separate all AI features into a separate kind of product called AI Studio. It's nothing really special. I mean, just the everything related to AI was named differently into Yandex AI Studio. And what's available inside? Basically, three things. One of them is like actually models. There are models that live in the cloud which you can easily call and use like for whatever reasons you want to use them. There are things that you can put around models to make them more powerful. I was saying about tool calling, like you are able to attach different tools, remote tools, MCP tools, like all that kind of extra harness to models. And this is called Agent Atelier. So there are different kind of features to make models more capable, to add different tools to them. And then it's also considered to be like a tool for non-professional developers. So Yandex definitely sees that more and more people, they are trying to use agents for their own work. And there are kind of interactive tools like Nathan, N8N, which helps build agentic workflows to people who are not really professional developers. I was taking part in a hackathon with one of the universities, like theatrical university, theaters. And there was one guy who was completely non-technical, but he used Nathan to build like a multi-agent agentic workflow to improve like the way plays are actually played in the theater. So that actually proved to me that non-technical people, they are trying to use those technologies, really advanced non-technical people. So Yandex understands that, and he wants to move AI Studio into non-technical world as well. So just to show you an example, I will just show you how that looks. So AI Studio is basically, it's available through web interface, aistudio.yandex.ru. And what you see here basically what I talked about. AI Playground lists all the models available, and Agent Atelier allows you to create agents here from the interactive environment. So you can say, I want to create an agent. You can select the model that you'll be using behind it. And the models, you see there are some Yandex own models, which is called LSAI, which is essentially a model trained on the high-quality Russian corpus collected by Yandex. Then there are a couple of Qwen models, DeepSeek model, and OpenAI open source models. So you can select the model behind your agent. You can select prompt, different parameters, and you can add tools. Like from here, you can add MCP remote tools, web search, file search, and so on. And basically, you can create an agent here without any coding. And once you do that, let me just create something. You can say view code, and it will give you essentially a piece of code that you can use to call this agent from any other programming language. So that is a way for not really technical people to do something. They can experiment rapidly, they can adjust prompts, they can ensure that the agent works and does what they want it to do, and then they can just give this piece of code to any developer who can build a simple application or a website, chat box, or whatever, Telegram chatbot that will interact with the agent. But that is not something I will want to talk to you about today. That was just to show you what is available inside AI Studio for non-technical people. So today, what I want to talk to you today, I want to show you the capabilities for developers, like how developers can use the features inside AI Studio. And there are two links that you might find useful. The one on the left is a kind of course which we developed for academia, for people, for professors at the universities to take and incorporate into their own curricula. So it's 8 lessons, like with Jupyter notebooks, with the samples of code, with presentations, which explain what I will be talking about today in 90 minutes in more length, like in more detail. So if you want to get deeper, you can follow the link on the left, and also you can just give it to people you know who want to learn about how to use agentic capabilities in the cloud. It's not only about Yandex AI Studio, it's also basically about any OpenAI compatible APIs. So it uses OpenAI compatible APIs. And the link on the right is the repository that I will be showing you today. So the code I will be showing you today is all available there, so you can play with it later on if you want to. So let's start with using the models, how to use models. OpenAI is a kind of de facto standard in providing models in the cloud because they were the first. And they have different generations of APIs. Like the first generation was text completion API, then there was chat completion API. And those APIs, they were pretty simple. Like you pass in the beginning of text and it returns the completion. But latest, like agentic capabilities, they require more difficult, more higher level APIs. And this is like the latest API family is called Responses API. And Responses API, essentially, it's the way to build agentic capabilities right inside the low-level API for calling the model. So it looks like pretty simple, like if you, in the beginning, you don't really see much difference from text completion. You create the OpenAI client, you select the model. In Yandex AI Studio, the model contains the special variable called folder ID, which is basically a string which identifies you inside the cloud. And that's it. You specify the base URL of Yandex AI Studio, and then you provide the system prompt, you provide the input message. And that's it. You get the response from the model. So let me just show you how that works. Let me show you how that works. Are you able to see the screen, or do you want me to make the font larger? Yes, you are able to see, or yes, you want me to make the large screen, large font? Large font, incredible. That would be really difficult for me, but very nice for you. Okay, so to use Yandex Cloud, you need two things. You need this folder ID. Folder ID is essentially this thing. In AI Studio, you have folders, and here you can copy the folder ID. And you need API key. API key you can create here. It's the special string of characters. So those two things you can, I put them in environment variables for simplicity. And then here what happens, I create this client. I define a few useful models, Qwen3, Qwen 3.6, and a special model for image generation, which I'll talk about later. And then like just to give you a short example, suppose I want to, since I'm talking about data processing, like data analysis and agent, I will start with a data example. Suppose I want to compare GDP, gross domestic product, of China and Russia. So I will create you a data analyst. Your goal is to help to analyze data, and I ask it to this question: please compare nominal GDP for Russia and China for every year from 2016 through 2026 inclusive. Express GDP in current US dollars, billions rounded to one decimal place. So of course, if I ask this question to an LLM, that is pure hallucination, what I'll get as a result. Well, pure hallucination is not really bad, because it would probably estimate the GDP like more or less correct. Definitely we don't want to use that for any serious research. But for an example, for just the demonstration, we can do that. And we'll see it takes some time to run, because we are calling the server somewhere in Russia. And we get the response. We get the response in markdown format, so the table looks beautiful, and that's it. Now, what if I want to continue the conversation? I can here specify previous response ID. So suppose I want to add one more column for US GDP. I don't need to pass the whole conversation again. I just pass the previous response ID, and it continues the previous conversation. So conversation is kept on the server side. That is kind of nice. Well, why is it nice? Can you think why is it really good? Because token caching works nice, because like the cloud understands that the first part of the prompt has been already passed through LLMs, and that's why it considers all those tokens cached. Why is it bad? Because you don't have control. Like if you do it like this, you don't have control on the conversation. You cannot compact it, you cannot like modify it. But if you want, you can. You can also pass the whole conversation again. Okay, so you see that it added one column for United States. So those were normal LLMs. The good thing about Responses API is that it is persistent. It allows storing sessions in the cloud and taking care of token caching. It is agentic. It supports, as we will see later on, tooling. And also it supports multimodal input. So you can have a model which takes text plus image as input and gives you, for example, text as output. So I can use the model to make a complement to a photograph. I say make a complement to this man, and it gives something nice. What I can also do, I can let's do one exercise. It started with one's personal story. I once went in a taxi through a city in Moscow, and I saw a really beautiful chimney, not this one, but even more beautiful chimney somewhere in the distance, which was really depressing, and I thought it would be really nice to photograph that. But I could not photograph that because I was running in a taxi like in the middle of the street. So what I did, I took the photograph using the camera in a really bad way, and then what I can do, I can extract prompt from that, and I can draw a photograph based on that prompt, right? And it would create me something similar to that. So let's try to do that. So I use the first LLM, the visual model, to describe a photograph, and then I will use another LLM to actually draw this photograph. So let's do that. So here I have the photograph, exactly this one. And what I need to pass it to an LLM receives text as input. So I need to encode it in base 64. So a little piece of code here encodes this in base 64. So it results in a big like string. And then to pass it to the model, I just say I have this input from the user, which contains input text and which contains input image. And I pass it to the model, and let's see what happens. In Yandex Cloud and AI Studio, there is one visual language model, which is Qwen 3.6 at the moment. There probably might be some others later on, and there used to be Google Gemma, which has been deprecated for some reason. So this is the prompt. So I asked it to create the detailed prompt, including lighting, colors, camera angle, and so on. So it actually created something really nice and detailed. And now I can use another API, which is also OpenAI compatible API, client images generate, to actually generate this image. So I say create realistic wide-angle industrial landscape based on this image description from previous example. And let's see what happens. It also gives me back base 64 text. I convert this base 64 back into the image, into the binary image. This is not very difficult exercise. And it used to be very fast, by the way, a few weeks back. Okay, so suppose let's wait and see how it works out. But what I want to do next, I want to show the example that agentic loop makes things better. So look what it created. Really similar to the original, but better because it's like nicely done, aligned horizontally and so on. We can also see like which one is better. We can pass this through VLM and say, please evaluate the result. So suppose I like want to select best pictures for the competition. I can use VLM to automatically do it instead of a photographer, right? But if I want to do something automatically, something like that automatically, I need to I need the output of LLM to be in some structured format, right? Because I want to, for example, to separate the grade, like how good the image is, from other things, like why is it good, why is it bad, those kind of textual descriptions. How do I do that? I can say, please return back JSON, but that is not a really good way to do it, because even if you tell the model, please return JSON, it doesn't always return JSON. It can return anything. In OpenAI, in Responses API, there is something called structured output. Structured output is when you specify the JSON schema, and Responses API gives you back exactly that schema. It can ensure that the schema is correct because it does check the schema during sampling, right? Because LLM provides like the distribution of probabilities for the next token, and you can select just those tokens which fit the schema. So in this way, you ensure that the output is always correct in terms of the schema. So here what I can do, I can define the class of result. So photographic quality, what is good, list of string, what can be improved, list of string, and then title. And I can say, please give me exactly this output. So in order to do that, I specify the text format equals eval result, and I also specify instead of client responses create, client responses parse. And it gives me back the object with all the fields. So you can see that the original photograph is quality 5, and the new photograph is quality 97, which probably means that VLM didn't do a good job. But that happens. Okay, so now let's do one more interesting exercise. We know that we can now generate images. You can now look at the images. So suppose I want to do something creative. I want to replace human artists with LLMs. Can we do that? So artists, what do? They come up with the idea, and then they think how can they show this idea visually, and that's it. And then they show it to their friends. Friends say it doesn't look good, and they improve something. So let's try to replicate this process using LLMs. I can start with some simple concept, and then I can ask LLM how to show this concept visually. The LLM would generate the prompt. Another model will generate the image, and then a third model would look at the image and say how well it reflects the original concept. So I have created the small application to do that, called Vibe Draw. So it's a web application which I can run locally, Streamlit application actually. And we will come up with a concept. We need just to think about something. What do we want to show in the visual form? Okay. What do you want to draw? A concept. Like what? Creativity, for example. So I start with this concept creativity. The first LLM thinks of the first prompt. Glowing light bulb made of tangled colorful paint strokes floats in the center of a dark empty studio. Then another LLM creates an image. And so on. So I will show you the results. I don't want just to sit for us to sit there and wait for the result, although it's kind of interesting feeling. Like it's always interesting to see what the model will come up with. But the reason I want to show you this example is that it actually shows how the image can improve through the agentic loop. Because once you have the loop, which is self-correcting, things can get better and better and better. So this is a good way to show creativity. Well, the model says 88% good. So recommendations: increase contrast, reduce focal noise, clarify the foreground. And now refined prompt, and yet another version of the image. So that would go on, I think, 3 times in this my application, or 5 times, I don't quite remember. Okay, so that is agentic loop. I actually made an exhibit for an exhibition in Moscow, which goes a little bit further than this agentic loop. It has 2 LLMs discussing between each other, like what is the best way to draw this concept. Like one prompt engineer, one artist, and they talk and talk and talk, and then they come up with the image, and then a critique does recommendations how to improve it, and then something like this is the result of this system. I actually like this ambivalence, like this girl with the face separated into 2 pieces. Looks good. Okay, now let me check the results. So you see, it kind of improves slowly. I don't know if this is better than the original or not. Is it worse? Well, light bulb at least is the right way. Kind of the right way. Who thinks it's worse? I think it's actually better. It's interesting because it makes you think, you know, like why, who decided to create the bulb like this? We know who did that. When. Anyway. Sorry? What is new? I still didn't get, sorry about that. Anyway.
Like recommendation.
Recommendation. Sorry. Recommendation. Recommendations are VLM looks at the picture, looks at the concept. So I asked it, does this image reflect this concept and how can we improve it? It is a loop. It is the loop. So it goes on and on and on. So iteration 2, recommendations. Then it creates the iteration 3 prompt, and then it goes on forever until it reaches 99%, which never happens. But yeah. Okay. So that was kind of fun part. Let's come back to serious things. Let's talk about tool calling. I mentioned that for agents we need two things. We need tool calling and we need agentic loop. Agentic loop we have talked about a little bit. For tool calling, does everybody know like how tool calling works? Or do I need to recap really fast? Come on, tell me something. Who wants? No, nobody wants to hear about tool calling. Okay, so the important thing about tool calling is that the model decides itself when it needs to do the tool call, and it doesn't do so really reliably. So it often makes mistakes. Like by often, I mean like in like 3% of the cases, 5% of the cases, and it's not doesn't seems like a large number, but if you want to build an agentic system really relies on tool calling. So it needs a lot of tool calls to finish the complex task. So if any of them can go wrong with a probability of 5%, then the probability that everything will go wrong becomes pretty high. So that's why tool calling is quite essential. So tool calling inside AI Studio can take different forms. Like the simplest form of tool calling is when you incorporate tool calling inside your code. So here, for example, is a short example how to add calculator to the LLM. Suppose I want to simplify for the LLM the task of calculating things. So I can say I want to add a tool which allows me to calculate any Python expression. So I create this simple Python function which calculates an expression. Then I define JSON schema, like what are the parameters of the call. Parameters are mathematical expression string. And what it does, description. So this is the description of the tool. And when I call the model, I pass the list of tools. I say there is a calculator tool. So if I do that, and I say, what is the square root of 2026, what I get as a result, I get the description that I want to call a function. The LLM tells me back, I want to call a function with this argument, expression sqrt 2026. So now I, as a developer, what I need to do, I need to understand that this is the function call. I need to actually call my function here somewhere, calculate expression, get the result, and pass the result back to the LLM. So if I do that, so I do it manually. The function is called, the result is obtained, then I pass the result back to LLM, and the LLM gives me back the answer. So that's how it works manually if I do this function calling by hand. What I can do, in addition to that, I can have local tools. like I have inside AI Studio and inside OpenAI as well. I have tools like for web search, so I can very easily add the capability to search in the web. I have the tools for file search, which is basically a RAG built into the AI Studio. So you can create the file index inside AI Studio and just say, I want to search on those files. And it would be like done inside the cloud. And you can have remote tools like MCP servers as well. So the good thing here is that, like, the beauty of Responses API is that you just do one call, and then the cloud, the AI Studio, does the rest. It calls the MCP server on your behalf and gives you back the final result. You don't need to do anything manually. So let's start with the example of web search. So for web search, I would use the same question about the Russia-China GDP, but I will pass the web search tool. So web search tool, I just say I want the type web search, context size medium, and pass it as the list of tools. And that's it. All the search is done inside the AI Studio. We don't need to worry about that. It happens automatically. I just get back the result. So even more powerful thing is code interpreter. So because like LLM cannot do many things, but it can generate code to do the things it cannot do itself. I showed the example with the calculator, which was pretty simple example, right? We asked LLM just generate an expression if you want to calculate it. But we can ask LLM to generate any code whenever it needs to do something. So now, while we wait for the web search results, I would improve this example even more. I would say, okay, I want to find the authoritative sources for GDP. I want to create forecast model to predict GDP, like in those years when it's not available. I want to create the files like this, including the diagrams, right? And in the final response, like summarize everything and create, do I say create PowerPoint presentation? I don't. Well, I just say create a lot of diagrams. And I just do one call, and I say tools equals code interpreter. And that's it. I cannot run it before the previous one finishes. I hope you will trust me that it should finish at some point. I will just stop it if I can. I cannot. So the code interpreter, what it does, it creates the very lightweight container, not the container like Docker container. It creates like really lightweight Python environment, which is protected inside AI Studio, so you are not risking to hurt any files on your computer. And it generates the code and runs the code there inside the container. So if it creates diagrams, they stay inside that container, and you can download them once you get the response back from the model. So that's what we do here. We get the response, and then we download all files which were generated. And hopefully we will see how it works. I can actually probably just interrupt the kernel. Restart the kernel. If I restart the kernel, I would need to really quickly rerun the previous code. Basically one. web search tool is not defined. Oh my God. Sorry about that. I normally try to give this talk when the internet is a little bit faster than here. Okay, so now what happens is the code interpreter would generate the code will run, I will get the result, and it will definitely take some time, and that's why I will continue with my speech meanwhile. So about MCP, I will not talk a lot about MCP, because I will just show what is available here inside AI Studio. In AI Studio, there is a special section for MCP servers. And what you can do, you can, for example, create MCP servers just by wrapping any REST APIs inside them. So inside AI Studio, there is a way to create MCP servers from many different things. Like you can say, I want to take Cloud Function. Cloud Function is a really cool thing in the cloud where you just write a piece of code which runs inside the cloud. You don't need to care where. You don't need to create virtual machine for that. Cloud does everything for you. So if you want to create like any piece of code that will run, that's a Cloud Function. So you can create Cloud Function, and then MCP server would call this Cloud Function. You can like have a number of predefined MCP servers like Yandex Tracker and so on, WordStat. Yeah, that is the special kind of layer which would help you connect different systems to your agent. Okay, so we were talking about Responses API. Responses API is already agentic in the sense that when I just do one responses call, many things can happen in the background. What can happen is that, for example, I can do web search. Like in my previous example, I asked here, I asked the model, please do the web search to find the GDP, and then run code interpreter to produce the graphs and do the analysis, right? So all that should happen in the cloud just from one call of Responses API. But it cannot correct itself if something goes wrong. So it's just one call. Well, if web search does not return the result, it would probably rerun the search. But if something goes terribly wrong, it cannot correct itself. So it doesn't have this kind of really powerful agentic loop, because when I need to solve really complex problem, I need really different tasks in a sequence, and the sequence would depend on the result of previous tasks. So that's why really agentic systems, they have this explicit agentic loop. And to do that, we can use the different kind of toolkit. What I will show you today is OpenAI Agents. OpenAI Agents is the higher level toolkit which sits on top of Responses API. And what it does, it allows you to create those kind of React agents which would plan, do something, observe the result, and then do something again. So suppose I want to do a thing similar to what Deep Research does in OpenAI ChatGPT, a thing which will investigate certain question for the user. So what it will do the web search, and then it will collect the search results, and then it will present like the report. So what I need to do that, I need to equip my agent with tools, namely web search, and I can also give another tool which is called Notes. Notes for keeping summaries of the pages found on the internet. So one of the main problems with agentic system is that the context cannot grow really high. If you just search a lot of things on the internet, it will fill the context of the model, and the model quality and the model performance will degrade, right? So that's why it's a good idea to explicitly like do this summarization, collect summaries of texts found on the internet into notes, and then you can look at the notes and create the report. So notes is a very useful tool here. How can we do that? Like, how can we specify that in OpenAI Agent SDK? We have a library called agents. So we install it, pip install it, and then we import different things from that. And we just say, please use Yandex model as the baseline model. Otherwise, like OpenAI Agent SDK is the SDK from OpenAI. So in order to add notes, like for web search, we know that web search is the built-in tool. For notes, I need to create my own kind of piece of code. And I can easily do that. I can just annotate functions with this function tool, and then I create a normal Python function, save note. It just puts the note into the dictionary, get all notes, which gives back all the notes, clear notes. So those are 3 tools that I will use. And then for deep research agent, I give him the instructions, like how it needs to do the research. And I say, I want to create this agent. Model would be Yandex agent model, instructions, deep research instructions, and tools, web search, save note, get all notes, clear notes, and code interpreter. Code interpreter is always a good idea. So as soon as this finishes, I will show you how that works. It's really a pity that it takes such a long time. 6 minutes. Okay, meanwhile, I will tell you what we are going to do next. Actually, I think I will interrupt and so if you want to see that for yourself, you can take the code and run it for yourself and enjoy, especially for those of you who are from Russia, when you come back, it would be hopefully much faster. Now, excuse me again, I need to rerun the first cell. So, as you have seen, sometimes those execution time can be really long. And of course, we don't want the user to sit there waiting, not knowing what happens behind the scenes. So that's why all the models, they support a special way of calling them, which is called streaming. So streaming, we essentially do the same kind of call, but we say, when we do the call, we say stream equals to true. So let me show you how that happens. So I start the agent. I say runner.run streamed, which means I want to run the agent in the streaming mode. And once I do that, the stream is basically a async for loop. So it's basically an iterator which gives back chunks, pieces of text, which model returns. And the pieces of text are deltas. So whenever it generates the text, it adds pieces of text. And there are also special events like MCP tool call, web search call, and so on. So we can, here there is a rather long piece of code which checks for different types of events and prints them in different colors, so that we have the nice output. So we see that now the deep research agent starts to run. It calls the tool clear notes, then it does web search, AI agents in software development 2026 impact trends. Then it does some other web searches which we do not see for some reason. So it does a lot of searches. And we can at least see that it's alive, but you see it does some kind of really specific queries because it processes the result of previous web search, and depending on the result of previous web search, it decides like what to search next. Okay, I will let it run for some more time, and I will continue talking to you. So when we are talking about agent systems, the important concept here is harness. Harness is the kind of tooling around LLM which makes it work in the most effective way. So keeping the context down to reasonable levels, creating this agentic loop, giving some specific tools like memory, file system tools, and skills as well. So those, the harness is an important concept. So OpenAI Agent SDK provides a way to build the harness around agents. So deep research, I have already shown you that. So in order to make it a little bit more fun, what I have done, I have wipe coded a small application, which is a textual shell for calling OpenAI agents. So what we can do here, instead of running this in Jupyter Notebook, because in Jupyter Notebook it kind of it's not as fun, we can write a separate application. Which is called MA. MA is the shorthand for multi-agents or for Mitya's agents. Mitya is my kind of short Russian name, which my parents used to call me. So this is this text application, and what it does, it looks for different subdirectories within agents directory. So you see here I have data analyst, deep research multi-agent, deep research with archive, and so on. And it has those like code from those directories available to you as you can chat with the agents defined there. So for example, the simple agent here is defined with just a few lines of code. I say, okay, I import agent web search tool. I define the variable called agent, give instructions, give tools, and that's it. So just basically a few lines of code. And here I can say it agent simple, and I can talk to him, hello. And it will give me the result. And look for GDP of China and Russia in the period 2016-2026. And it would do the web search. So it basically does the same streaming as in Jupyter Notebook, but in a little bit more beautiful way. It streams also the reasoning. This is the response from the model. Then it does web search. Then it does again web search. You see it found some numbers. And then it would come up with the result. So I can basically run the same kind of example as here. You see here it finally did all the web searches, and then it produced some search result. It started saving notes, saving notes, saving notes, saving notes, and then it come back. I think it still runs, right? So now it executes codes to generate output. So it is really long-running call. So I can do the same call here. So what I want to show you next, let's try actually this deep research. I would say agent, and switch to, let me do deep research with archive. So deep research with archive, let me show you the code again. So here I have the MCP server for searching the archive preprint repository. This MCP server runs in AI Studio as a cloud function. So that is basically what I have told you before. I have created cloud function which does the API call to archive, and this is the just URL for the MCP server. For MCP server, I just need to provide the URL, nothing else. MCP server automatically defines what tools are available. And this server in particular gives two tools to do the search and to get details for a specific paper. And now the main agent, we give him like long instructions, web search tool, archive tool, and we also give two specific tools for notes and for to-dos. To-dos are good for keeping like what the agent still needs to do, like an agenda. Those tools are built into this textual environment. So what I can ask it, let me start the new conversation. What are the trends for multi-agent systems, let's say in education? You see those tools with notes and with to-dos, they are available here in the interface, so we can easily see like what the agent does. And for some reason, agent started to reason and create to-dos in Cyrillic. This was really not clear to me why that happened, because the system prompt was in English, everything was in English, but still from somewhere the Cyrillic came through. And what I realized is that the built-in tools like web search, they contain their own system prompts in Cyrillic inside the AI Studio. So that's why Cyrillic came through. And we need to actually ask the agent specifically, please do not use Cyrillic, just use only English, in which case probably it will do better. So now what is happening, the deep research started working. It would go through all the to-do items. It will collect notes, and then it would create the report at the end. So this is single agent system, right? Why might we want to create a multi-agent system out of it? So why we need multi-agent systems at all? One of the reasons is that the LLMs, they are not good when they have many tools, because because the way LLM does tool calling is that it receives the list of all tools, right? So if there are 30, 50 tools, then the LLM cannot reliably choose between them. And as we have already mentioned, maximizing the probability of correct tool calling is important. So to minimize the number of tools, we can separate tools between different agents. In our case, in the deep research, it's probably not the necessity, because like we don't have many tools, we just have like a few. But if we have more complex system, that becomes a useful thing to do. So for example, how can we separate the system into different agents? We can, for example, start with a planner agent, which will take the original request, create a to-do list, like what needs to be done, like separate this topic into subtopics. Then the researcher would go through each subtopic independently, create the notes, and then a writer would create the report from the list of collected notes. So that's one of the reasons, minimize amount of tools. A second reason is to minimize the context used, because for example, if we separated big topic into subtopics, we can ask sub-agents to research those subtopics independently. They can do it in parallel, which would be faster, or they can do it in their own context without like creating big conversation, right? So that is another reason to create multi-agent systems. And the third reason can be management reasons, like for example, if we have big organization, and certain departments, they are responsible for different kind of pieces of work process, then each department can build their own agent, and those agents would talk to each other. So what are the main mechanisms for building multi-agent systems in OpenAI Agent SDK? Basically, there are two mechanisms. One mechanism is called handoff. So when we have an agent, we can say, you can hand off execution to another agent. Like planner agent, we can tell him, please do the planning, create the plan, write the to-do list, and then hand off to searcher agent. Handoff is implemented as function calling behind the scenes. But what it does is that different agent starts executing, and this agent gets the full history, full dialog history from the previous agent. So handoff doesn't truncate the context. It like uses the full context, and it's one way. So we hand off to another agent. We cannot come back. So in this architecture, for example, handoff is really natural. Like from planner, we go to researcher, from researcher, we go to writer, and then we go to output. The way it works in practice, here I have an example, deep research multi-agent. It is exactly built with handoffs. So I have summary writer, which writes the summary, and I have the researcher agent. Researcher agent can hand off to summary writer, and I have main agent, planner agent, which hands off to researcher. So this is the simple three agent system. And we can start it here. This one agent system created the research for us. So this is the report. Pretty long. So let's now quickly start with multi-agents. What actually we can it starts with planner. Tool call is probably MCP call. And here, because it's handoff, we will see like the full history. Sorry, we'll see the full history, like the agents give conversation from one to another. Another way to do agent coordination would be to create a separate agent called coordinator. So coordinator would receive the task from the user, and then it would decide like which agent to call. This can be done with handoff, bidirectional handoff, but it can also be done using agent test tools. Agent test tools means that coordinator actually calls another agent, passing the question to this another agent, and then it gives back the answer, not the complete history, just the result. So this is exactly the way we can use in order to save on the context. Like for example, planner would do the planning, it would return back to do items, but it will not poison the complete history with all the tool calls, with all the conversations. So that would create much more compact context. It will of course miss some of the details. So whenever you have any problem, you need to see like which architecture of multi-agent system would work better in your case. Agent test tools, essentially easy. You just say searcher tool agent dot as tool, and that's it. So there could be many agent communication patterns, and in general, the important thing is that once we create this kind of workflow between agents, like for example, when we for research agents, we say first plan, then collect information on the internet, then search, and then write the report. We, as the creator of the system, add additional like guidelines, hard guidelines, how the agents should behave. And it kind of makes the system more stable, because we tell the system what to do. Unlike if we have one agent, the agent decides what to do by himself. And that is much less certain. So in basically, like if we look at the spectrum of those agent systems, there are systems which rely on completely rely on LLMs, and those are systems that do deep research, that do exploration, and which are not designed to run really reliably every time. And then there are systems which business uses more, which are based on graph execution. So we have number of steps. Each step is driven by the LLM, but then transition between those steps is kind of hard-coded. So we decide explicitly where the execution should go. And those are libraries like LangGraph. They support exactly building those kind of rigid graphs. And in real life, like we need to decide which way to follow. And if we have precise control of the graph execution, we can take smaller, less capable language models, because like if something goes wrong, that's not too bad. The graph would still recover. While for complete multi-agent systems with this kind of more flexible React approach, we need more capable LLMs. Okay, so finally, what I want to show is the final result here. I promised that we will build our own data analysis agent. Data analysis agent can behave like the data analysis agent. The goal is to allow user to say, here is my CSV or Excel file, please analyze it for me, like do certain kind of research. So what it needs to do, it needs to be able to pick the data files from the current directory, put it into code interpreter, run code interpreter and do something, and give back the result. So for this, we need file system tools, which would list files, like upload files, and so on. We need the tool to inspect a file. So if it's an Excel or a CSV file, we want to know like what are the columns and so on. And we can also add something called skills. Skills are specific like text files which tell agent like how to solve certain tasks. So here, data analysis agent, I will just briefly show you the code, how it looks. It's called pro-analyst. We have the directory with skills, and skills are data exploration, docx document, markdown to PDF, PPTX presentation. So each skill is basically this text description, how to do what it needs to do. Like, for example, if you want to create a presentation PowerPoint, I say clarify the audience, I prefer concise structure of the presentation with those chapters, save the deck as PPTX. And again, the agent has the list of all the skills that are available to it, and then it decides like which skill does it need, calls the tool to load the skill into context whenever it needs the skill. So this is kind of notion which is used a lot in all programming agents. Here it's built manually, like by hand. And you can see that, so this multi-agent, by the way, system finished. And let me show you where handoff happened, somewhere before the report. Somewhere, so this is still researcher. So somewhere, let me not, yeah, here, for example, transfer to summary writer, right? I have collected all the notes. There is a tool called transfer to summary writer, handoff, call item, and agent becomes summary writer. Another agent takes over and continues the execution. Okay, so finally, let me show you the final example. So I have here the gdp.csv, which is the CSV file with GDPs of different countries. And I start the agent in this current directory. I switch to this pro analyst agent, and I say let's analyze all data files in current directory. Of course, I can ask like specific files, what I want to do, and so on. But here, what it does, it calls the file list tool, finds that there is a GDP CSV file, loads the skill because I asked analyze file, so it loads the skill for doing data analysis, and this skill describes like what does it mean to do data analysis. It checks the data set, so does the file inspection. And the way this this agent actually looks, like if you look at the code is pretty simple. Like again, system prompt. In the system prompt, we include the metadata from all skills. So we load all these starting lines from each skill, included into the system prompt, so that it knows which skills are available. And that's it. We have the container. We use code interpreter as the agent tool, and we have two more like set of tools to work with skills, like loading skills on demand, and tools to work with file system, including file upload. So that's basically pretty simple harness around the agent, and it can still do a lot of interesting things. Okay, I think I will pretty much. Yeah, there is also one more agent which I will not show you because I probably don't have time already. Which is Kaggle Data Analyst. It goes to Kaggle. It can search for data sets. So you can ask, for example, I want to know like who sleep better, men or women, and it will find that data set which is related to this and try to analyze it. Okay, so takeaways from this talk. First of all, Yandex AI Studio is, I think, the only provider in Russia which provides full support for OpenAI compatible APIs, which is really good because all the tools that use OpenAI work out of the box. Well, almost in all cases. In addition to that, in Yandex AI Studio, you have some nice capabilities, like you can do model fine-tuning easily, which is a lot of fine-tuning, but you don't need to worry about where to train the model, how to deploy it, and so on. But it is only available for lightweight models like Yandex GPT Lite. Creating multi-agent systems is not a difficult task if you just look at the code, but of course the difficult task is to build the correct harness which would work correctly in your specific scenario. That's it. Any questions that you have, I would be glad to answer. If you like to read about something related to AI and education and art in Russian language, then I welcome you to my Telegram channel.
Okay, thank you. How do you select the models that you present in your interface? Like for VLM, for LLM, and kind of.
You mean how does Yandex select the models?
Maybe, yeah, yes.
I think there are many considerations. First, probably what would be the demand, like what people are like to use. And the reason that we cannot host many models inside the cloud is because that's the complex engineering task. Like having many models requires many like specific instances running all the time. And as we know, in the cloud, we need like to take the advantage of economies of scale. We cannot have the server, which, for example, is works during the day and doesn't work during the night. So we need like to ensure there is a constant and large demand. So that's why the amount of models which are always available is rather limited. We have seen the list is not very long. There are also other ways to run models. There is something called dedicated instance, where you can start, like, you can say, I want this model, and I am ready to pay for the server behind it. Like, not exactly in this way, but that's what it means behind the scenes. Like, you pay all the time a certain amount of money, and then the model runs for you. You have the like guaranteed performance because its server is dedicated for you, but it's not you always pay for something, so that's not really but if you want specific models, the list of models which are supported via this dedicated instance is really huge. And also there are many cases where you just need models to do data processing. Like, for example, you have a lot of forms filled by someone, and you need to run a visual language model on top of them overnight. And that is another possible way to run the model. It starts up the server, runs this big batch, and then it stops the server. So that is also a possibility. I guess I answered slightly different question, but I think that's what is important to mention.
Okay, and second question, do you have some programs available for students or universities to try your tools, like maybe for free or maybe kind of?
Anyone can try the tools for a certain amount of time for free. Like when somebody registers on Yandex Cloud, he receives the credit, welcome credit, which he can use. But that is not a lot. If you are doing some kind of research project on Yandex Cloud, you can apply for the grant. There is a specific grant for educational institutions and for research purposes, which is pretty easy to receive, I think, because it's not really a long formal process. There is a form on the site, you fill it in, it goes to like a couple of specific people, and they look at it and they say, okay, they evaluate like whether it's a good idea or not, and then they provide you with some grant which you can use for the research project.
Thank you a lot for your question.
I think when they look at the project, they look well. First of all, it should be kind of nice looking project, so that it can potentially make a good PR, or it's potentially for a good cause. If you say just I want to, I don't know which example to give. I want to process all the records of our students in our university for the last 10 years. That is not particularly a good cause, because it's just some kind of administrative work. If you say I'm doing a research project which will help me recognize certain rarely used languages, or I want to create a handwriting recognition for like something, that is a good cause. That is something which is likely would receive the grant.
Okay, thank you. Any more questions?
Thank you for the lecture. My question is actually simple. What was the best scenario for you to harness this agentic system, maybe for you personally, or for the business, or for a project?
Well, I think that the best way depends on the problem. The reason I gave examples like of economic, like GDP kind of data investigation, is that currently we are working together with a group of students on one of the projects to do basically an assistant for economists to create certain data sets. Like, for example, if a person wants to know like what are the economic relations between two countries, there are a number of economic indicators which can help derive that information. There is no direct data set, like, for example, which compares two countries like, for example, Armenia and Cyprus. they are just not in the same region, and there is no existing data sets. And what we want to do is we want to give it access to a large amount of economic data via MCP or some other kind of way. And we want the agent to be smart enough to understand like what does it mean by economic relations, to explore like import, export, and those kind of different indicators. And yeah, we are basically what we are doing. We are trying different approaches. Like we are trying the approach with the graph, where we first do the planning, like what indicators we need to look at, and we use like we use graph. A representation of the economic book, like what are the basic concepts, how they are related to each other, and so on. And we use the flexible React approach as well, and we want to see like which one would work better. So I think that is the probably reasonable way to do it, because to predict it beforehand, like which one would work better, it's kind of difficult. But if you have the real life problem, I think the main decision is whether it's a research question. Like, for example, economic research is a research question. If something goes wrong, a person can run it again and it would produce a good result. Nothing bad would happen. So in this case, you can rely on flexible React agents. If it's a business scenario when a customer comes and the customer like fills the form, and then in half of the cases it works, and in half of the cases it doesn't. That's a bad thing. That's why in the business, in customer-facing scenarios, it's mostly always about graphs and like more controlled execution. I don't know if I answered your question, but
that was interesting scenario of using. Thank you.
Thank you. No more questions. Thank you so much. I wish you the good rest of the school.